We shall now move on to the next chapter, states of matter. You have studied about 3 different states of matter: solid, liquid and gas. For example, if we consider water, we know that water exists as solid ice, liquid water and gaseous water vapor. So water can exist in 3 different states. Now when it exists in 3 different states, there is no change in its chemical composition. Whether it exists as solid ice or liquid water or gaseous water vapor, the chemical composition is the same. It is H2O in all the 3 cases. But the physical properties are different. Why is it necessary to study about the different states of matter? It is because when we do experiments, certain measurements will be taken and the values obtained will have to be used to do certain calculations. So it is found that to do these calculations, we need the knowledge of the state of matter. So it is necessary to know the laws which govern the behavior of matter in different states. It is found that the nature of intermolecular forces, molecular interactions and the effect of thermal energy on the motion of particles together will determine the state of a substance. A substance can exist in a definite state. Now what will decide the existence of a particular substance in a particular state? It is the nature of intermolecular forces, molecular interactions and the effect of thermal energy together which will decide the state of a substance. Let us now study in detail about intermolecular forces. Intermolecular forces means these are the forces which exist between different molecules. Intermolecular forces are of 2 types. It can be either forces of attraction or forces of repulsion. Now what are attractive intermolecular forces known as? Attractive intermolecular forces are known as van der Waals forces. So next we will be studying about 3 different types of attractive intermolecular forces. Dispersion or London forces. This type of attractive intermolecular force exists among atoms as well as nonpolar molecules. We know that nonpolar molecules will not have any dipole moment. Now consider the atoms A and B given in the figure. In the beginning, there is symmetrical distribution of electron cloud in both atom A and B. But at any other moment of time, this symmetrical distribution of electron cloud may be disturbed in atom A. So as a result of this, the electron cloud will get shifted to one end of the atom in atom A, and that end of atom A will now become the negative end and the other end of the atom will now become the positive end. So we can say that a dipole is thus created in atom A, which is known as instantaneous dipole. Now this instantaneous dipole created in atom A will disturb the symmetrical distribution of electron cloud in the neighboring atom B, as a result of which the electron cloud in atom B will also get concentrated onto one side of the atom, and that end of atom B will now develop a partial negative charge, and the other end of atom B will now develop a slight positive charge. Thereafter, there will be attraction between the positive end of one atom A with the negative end of the other atom B. Now the dipole which is created in atom B is known as induced dipole because it is induced by atom A. So this type of attraction which exists between temporary dipoles is known as London forces. It is found that the interaction energy is inversely proportional to the square of the distance, and this type of force exists only or operate only for short distances. Dipole-dipole forces. Consider the next type of attractive intermolecular forces. This type of force exists among molecules possessing permanent dipole moment. For example, consider hydrogen chloride. 2 different atoms are present, one is hydrogen and the other is chlorine. And we know that chlorine is more electronegative than hydrogen. So the shared pairs of electrons will be attracted more towards chlorine than by hydrogen, as a result of which the chlorine end will develop a slight negative charge and the hydrogen end will develop a slight positive charge. So HCl molecule possesses a permanent dipole moment. Now consider two HCl molecules which are close to each other. The chlorine end of one HCl molecule will be attracted by the hydrogen end of the neighboring HCl molecule. So this type of attractive forces which exist between two different dipoles is known as dipole-dipole interactions. Now consider the next type of attractive forces known as dipole-induced dipole forces. This type of attractive forces exist between polar molecules having permanent dipole moment and the molecules lacking permanent dipole. It means one molecule should be a polar molecule and the other one should be a non-polar molecule. Now consider the polar molecule AB. Here B is more electronegative than A. So the shared pairs of electrons will be attracted towards B, as a result of which B will be the negative end and A will be the positive end. Now this polar molecule will disturb the symmetrical distribution of electron cloud in the non-polar molecule, as a result of which the electron cloud in non-polar molecule will get shifted to one end of the molecule, as a result of which that end will develop a partial negative charge and the other end will develop a partial positive charge. Thereafter, there will be a force of attraction between the negative end of the polar molecule with the positive end of the non-polar molecule. So this type of attractive force which exists between a polar molecule and a non-polar molecule is known as dipole-induced dipole forces.